In this video, we're going to solve print n-bit binary numbers having more ones than zeros. Although it is given more ones, but in the problem statement you can see more than or equal ones. Okay. So what does this mean? We'll be given integer n, and we have to print n such binary numbers where count of 1 is strictly greater than or equal to number of zeros, count of 0. So see, for n equals to 2, what we can get is 1 1 and 1 0. See, in both the statements, either number of ones and number of zeros are equal, or number of ones is greater than number of 0. Cool. Similarly, for next example, n equals to 3, there are three outputs: 1 1 1, here again 1 greater than 2 greater than 0, then 1 1 0, then again two ones and one zeros, so n greater than 1, and again 1 0 1. So here again number of ones are 2 and number of zeros is 1. So again count of ones is greater than count of 0. But you can see here in n equals to 2 we have a output where both number of ones and number of zeros are equal. So I'll be solving this question using recursion. So first of all, I'll create an empty variable called output. As you know, in this kind of question, when we form input output binary tree, so as soon as our input becomes 0, then at that level of binary tree we have our answers. We get our answers. And apart from that, I create an empty list, empty array called list. Here again number of ones and number of zeros. On is 1 and z is 0. I will initialize it with 0 because unlike balance paralysis question, here we have to start from 0. I mean, number of ones and number of zeros will be 0, and then we will form the string, okay, from the integer number and binary number. Then as we go ahead, I will create an utility function having output ones, zeros, and n, okay, as the arguments. So the first base condition is if n is greater than 0. I mean, there are no numbers, or we have already formed all the possibilities, which means input becomes 0. Then in that case, I will append this output to the list, okay, and I will return from here. But if that's not the case, and we are still having valid inputs, then there can be two conditions: either number of ones is equal to number of zeros, or number of ones is greater than zeros. Let's say move ahead with first condition when number of ones equal number of zeros. In that case, we will recall our function with, again, now since 1 and 0 are same, we can again call our function with an additional 1. Okay. So I appended 1 to the output, and number of ones increased and number of zeros got no change, and n minus 1 because we have included 1, we have added 1. Now apart from this, if that is also not the case, which means number of 1 is greater than number of zeros, it means 1 greater than 0. In that case, I will again call our function with two possibilities: either I will append 1 or append 0 to the existing integer binary integer, okay, binary number. Then first let me add 1, append 1, then since 1 got added and zeros, number of zeros remain unchanged, and minus 1. Then again, let's say this time I move out to add what, 0. Then this time number of ones remain unchanged and number of zeros got increased and decrease the n. That is it. And after that, our function will work like magic. That's what they said. And its output 1 0 and n. And let me return the list. Let me submit this for you. Yes, it did solve in pretty less time. Okay. Thank you. Have a nice day.